Hello, today we're going to be talking about Physics 252 Week 6 problem number 3. In this problem, we are asked to find the sound level in decibels that an observer would notice from a rocket explosion at an altitude of 100 meters. So in the setup for this problem, we're given that the observer directly underneath, so at a distance of 100 meters here, here's a sound of 100 decibels. So here's our launch pad, here's our rocket, and it's exploding. In this case, it would be a spherical emission of sound because there's nothing dampening the sound in any way. It's just kind of traveling outwards in all directions, which comes in handy later in the problem. But here's our observer at 100 meters away. Obviously not to scale, but yeah, let's get into the problem. So some of the things that are going to be helpful for this equation is this equation right here. And what this does is this tells us, this kind of relates sound in decibels to intensity of the sound. And if we remember from lecture, the sound increases at a logarithmic rate. So that's the reason for this log here in the equation. We also have our intensity given, or our intensity given power and the type of emitter of sound. So in our case, as I mentioned, it's going to be a sphere. So this is the equation for a sphere right here. We also have the threshold of human hearing, I naught, which is this value here in watts per meter squared. So getting into the problem, we notice that we can use this equation. Using this equation, we can rearrange for intensity, because what we're going to do is we're going to solve for the intensity at 100 meters. So plugging in our values here, where this is decibels, we're given this intensity right here. And from here, we can plug this into our power equation to get the power of the sound. So just doing that, rearranging the equation here, and then plugging in our variables here, because it's a 100 meter radius for the sphere here at this point. So we're left with this number here, this number here in watts. And from here, we can plug this back into the equation, the same equation, and solve for intensity given power and radius. So that's what we're doing here, but we're upping the radius to 100 or 1,000 meters here. And from there, we can solve for the sound in decibels at 1,000 meters. So again, using our threshold of human hearing and our equation up here, we can just kind of solve algebraically, and we end up getting that the sound at 1,000 meters that someone would observe is 80 decibels. So thank you very much for watching, and I hope you found this video helpful.